So hello again and welcome to BlockW webinar on AI, regulating AI and the AI Act. Joyce O'Connor here, founding member and chair of BlockW. BlockW is a female-led NGO whose mission is to create awareness about blockchain, AI and other emerging technologies and to ensure equity, diversity and inclusivity in its use and application, to highlight pathways to education, training and skills development, and to encourage research and inform policy. Today's webinar is on AI, as I said, in particular AI, regulating AI and the AI Act. And it's my great pleasure to welcome our distinguished speaker today, Professor Barry O'Sullivan. Barry, you're very welcome and thank you so much for taking time out of your very busy schedule to be with us today. I really appreciate that. So thanks again.
No problem, Joyce. Thanks for the invitation. So shall I just start? And
No, I'd like to give a little introduction, if I may.
Oh, sure, of course, yeah.
I know you're a modest man, so don't mind me. I have to tell them who you are.
Okay.
Barry is a full professor at the University College Cork in the School of Computer Science and IT and is a member of its governing body. He's founding director of the Insight SFI Research Centre for Data Analytics at UCC and director of the SFI Centre for Research Training on AI. In 2019, Professor O'Sullivan was appointed Vice Chair of the European High-Level Expert Group on AI. And this group really published key publications on ethics guidelines for trustworthy AI and policy and investment recommendations on trustworthy AI. Barry is an advisor on AI to the European Commission's Joint Research Centre. He's currently chair of the National Research Centre, or National Research Ethics Committee for Medical Devices, and a member of the Enterprise Digital Advisory Forum and chair of the Oversight Committee on Data Research in the UK in the North. Professor O'Sullivan has received many awards for his work and is a recognized expert in AI at a national, global and international level. He's played a key role in strategic planning in the Irish and European arena in relation to AI. He's a chair of and an active participant in a range of national, European and global forum on AI matters. So we're very lucky, Barry, to have you to be with us today. I'm just going to give a little introduction to the AI Act, Barry, just to give it a context. The proposed AI Act uses a risk-based approach to classify AI systems with different requirements and obligations according to their intended purpose and level of risk. A number of questions are raised. Is this new framework based on the right principles and approach to foster innovation and trustworthy AI solutions? And what impact can we expect on AI providers and users? The European Commission proposed that the AI Act should become a global standard if it is to be fully effective. Will the AI Act boost the uptake of AI and guarantee a human-centric approach? So Barry, your presentation is very timely. Last week saw the introduction of the AI Act of the European Parliament, but as they say, a lot done, but more to do. So we look forward to your presentation.
Thanks. So I suppose I'm going to start right at the beginning in some sense, and talk about, I suppose, AI per se, then talk about, well, how does one even begin to think about regulating AI? So that comes from, I suppose, the field of ethics, and there's been a huge amount of work done on the ethics of AI over the last number of years. And then we'll move into the AI Act and the details of it. And I suppose, as Joy said in her introduction, this is a very important piece of legislation. And I guess it remains to be seen how effective it is and if it's taking the right approach. And there are a couple of characteristics of it which I find a little unusual, which I'll highlight at the end. So, for example, the AI Act is something that really classifies use cases rather than techniques and technologies. So it's a piece of legislation that in some sense regulates the end rather than the means. And I think that's kind of unusual. And I'll explain what I mean by that in a few minutes. But before we start, let me just give you a sort of an overview of AI a little bit. And I'll also touch on the kind of the current discussions around things like ChatGPT and so on, and why I think we don't need to be so afraid of these things. There's a lot of dystopian kind of coverage of these things in the media, but I think there's a lot of overestimation of their abilities. So let's talk a little bit about that. So first of all, if anybody listening wants to reach me, you can just take a photograph of that there, and that'll put the details on your phone, and you have the details right there. So feel free to reach out if you wish. I'm very happy to take questions and so on. Arthur C. Clarke said that any sufficiently advanced technology is indistinguishable from magic. And of course, I think this is very true of AI. People sort of, they project onto AI these magical properties, that this is a technology that, in a sense, is creating an artificial replica of a human being in terms of our abilities, in terms of our intellect and so on. And I think that's really far from the truth. I think everybody who's listening to this is using AI every single day, be it the system that recommends movies for you to watch on Netflix or songs to listen to on Spotify, whether it's the filter that takes all the spam out of your inbox and puts it in a spam folder, the voice assistant on your phone, Siri or Alexa or something like this. These are all systems that people use every day. Even maybe more mundanely, the satellite navigation system on your car, the Google search engine. These are all examples of AI systems. And of course, they're not human-like at all. You know, they're providing assistance. They're automating things that would have previously been very, very difficult. And so I guess one of the reasons why people often think that this is a magical technology is that they're surprised by the abilities. So, for example, with ChatGPT and large language models, I think people have been surprised at how good the output actually is. And I think that surprises people. And as a consequence, they think, well, this does really feel like magic. But of course, once you look under the hood, you very quickly discover that that's really not the case. The other quote that I often use when describing AI is a thing called Amara's Law. And Amara's Law says that we overestimate the effect of a technology in the short run, and we underestimate the effect of it in the long run. Mm-hmm. And so I think we often believe that some technology is going to completely revolutionize the world very, very quickly and very disruptively, but that rarely tends to happen. What tends to happen is over the long term, technologies tend to sort of seep into the environment around us in some sense, and slowly but surely really do transform, but over a long period of time. And a very good example of that is of course, the iPhone. You know, when the iPhone was introduced, I think we thought that this was going to be completely revolutionary. We're going to be reading everything on these handheld devices, and we finally had a calculator that we could all actually see. But of course, we didn't really understand that in the longer term, that the world was really going to change as a consequence of these handheld devices. And of course, we've, you know, some would argue that we've kind of lost ourselves into these little rectangular screens in a way that we never would have predicted. So that's an example of Amara's Law. And of course, AI is strewn with examples of hype cycles and bust cycles. We tend to call them AI summers and AI winters. And I think today we're probably in the third AI summer. And of course, the winter happens when the technology overpromises and fails to deliver. And so people sort of move away from it to some extent. And that has certainly happened in the past for AI. Maybe not this time around. I think this time is somewhat different. It's worth today just mentioning that Ireland has significant track record in AI and the establishment of AI. So George Boole, who was the first professor of mathematics at UCC, wrote The Laws of Thought, the first book that really kind of developed a systematic approach to thinking. Alan Turing, whose birthday is today, we're recording this on the 23rd of June. So this is Alan Turing's birthday. I highlight him as in the context of Ireland, not because he was born in Ireland, but his mother was born in Ireland. She was born in County Clare. And for those listening in Dublin, his parents were married in St. Bart's in Dublin, which is often sort of overlooked. John McCarthy, of course, is a first generation Irish immigrant to the United States. His father's from Cahersiveen, and it was John who really coined the term artificial intelligence. And so we can claim some ownership there. And of course, while Geoffrey Hinton, who many people will know as one of the fathers of deep learning, isn't Irish, he is in fact the great-great-grandson of George Gould. And I think it's very interesting that that the story of AI, the story of moving from the logic-based approaches to AI to the more data-driven machine learning approaches to AI, is also the story of a single family, and so and a very brilliant one, of course. AI, of course, permeates everything, as I say. We often hear of great advances in things like game playing. So many will remember when Kasparov was beaten by Deep Blue, and when human beings were beaten at Jeopardy by IBM Watson. There's great hope for self-driving cars, although I think, again, that technology has been somewhat overstated. I think maybe 5 or 6 years ago, there was a belief that that autonomous driving was a solved problem, and that it was now just a regulatory issue. But of course, that really hasn't happened at all. And we still don't really have autonomous driving in Ireland for all sorts of reasons. There have been some interesting claims around things like robotics, and on the bottom right here we have Sophia the robot, this humanoid robot who has been given citizenship in Saudi Arabia. But of course, there's nothing sophisticated going on in Sophia. It is in some sense a ruse. It gives the impression of something that really isn't. It's an illusion. But there have been really amazing applications. But of course, some of them come with great ethical concerns. And so in the center of this, you see this mannequin. This is an IC mannequin. She has cameras as eyes. And on the screen on the back, you'll see that there are various analytics that are being gathered from the cameras that are in the eyes. And so this is predicting the gender, the age, the race of the person who's looking at the clothing on the mannequin. And of course, using that then to make certain judgments about the people, and maybe also trying to use that data to later upsell as you go to pay for the clothing that you decided to buy. And so this raises all sorts of other interesting issues in the ethical domain. Lots of people are talking about ChatGPT. When people ask me to talk about ChatGPT, I show them this slide. This is ChatGPT. This is the guy who sits in every pub in Ireland. You can ask him anything you want, and he will, out of no sense of harm whatsoever, he will wax lyrical for as long as you wish. He may sing the song. He may recite some poetry. He will remember something that he thought he heard some time ago, and put it out as fact. That is ChatGPT. And really, do you think that this guy is going to take over your business? Would you trust him to run your business? He's very entertaining to interact with. We all love him dearly, but it's a system that's far away from being something we can absolutely rely upon, despite the fact it is very, very impressive and very entertaining. So what is AI? I suppose, first of all, there isn't a standard definition of AI, which is surprising because the AI Act is going to regulate it, right? So it's going to regulate something that isn't well defined. And later I'll talk about the specific definition that's in the AI Act. And I'll comment on that. But my preferred definition is a system that it's a computer system that performs a task that is normally regarded as requiring human intelligence. Now, that definition will get you through a radio show if somebody asks you what is AI, and you can sort of say things like, well, it's those things that do things that seem to require human intelligence to perform them. Playing a game, understanding language, understanding videos, being able to plan. But this is far too broad a definition for regulation, because of course there are lots of computer systems that are just simply programmed by humans that satisfy this property. So there's lots of things that we would not regard as AI that are caught by this definition. And I suppose there's also a difference between the methods and the algorithms and the system. So the difference being, like, as the academic field of AI is all about developing methods and algorithms of doing things. And of course, then these are rolled up into systems that perform useful things for us, like the recommender system on Netflix, for example. And of course, it's important to realize that the ethical issues don't really arise in the methods and algorithms to a great extent. They really arise when the technology needs a use. And so it's there that we need to start thinking about, well, how do we regulate? A major problem in AI at the moment is incorporating common sense. And a very nice book written by colleagues of mine, Gary Marcus and Ernie Davis, is well worth a read, Rebooting AI. So building AI we can trust. And this is really all about, well, how do we make sure that AI systems actually understand the world in which they operate? And this might sound like a surprising thing to argue that AI systems do not have, but they do not have it. Most AI systems are built on data by looking at correlations between things and no notion of causality, for example. In other settings, in order to really understand the world, you need significant knowledge about how the world works and the various sort of fears and properties of individuals and roles and people and so on. And this is extremely difficult to build into AI systems. We've all heard of the problem of bias. So AI systems are not per se in and of themselves biased, but of course they can be built in a way that magnifies human bias, because the data in which they're built upon might contain human biases, and this is very difficult to eliminate. And of course, we do need to make sure that AI systems do not amplify these biases. And so again, this is a huge focus in regulation of AI. How do we make sure that the AI systems don't discriminate against us racially or from a gender point of view or from a socioeconomic point of view and so on. And there are all sorts of subtle forms of bias. So, here on the left-hand side is a set of search results for cute babies that I got from Google. And, it looks harmless enough, but they're all white babies, right? So the algorithm has decided that because I'm a middle-aged Irishman, that I'm more likely to find these babies cute, which of course they are cute, but lots of other babies are cute too. So, but this is a bias. The algorithm believes that I will like these more than others, and of course that is a bias. We could argue whether it's a very, very harmful one or not, but in certain contexts it is extremely harmful. There are other issues around training AI systems using language, where the language actually has baked into it gender biases. So we all know that some languages have gendered nouns, for example, and the gendering is something we might not really think about, but when we train AI systems with it, it is very difficult to separate the gendering from gender bias and from discrimination. And so it's really, really difficult to deal with these sorts of things. And of course, then there's a question of how do we measure bias? So the famous COMPASS system, which is this system that does parole recommendations it makes recommendations to judges on parole based on the likelihood that a certain individual will re-offend. And there's a long-standing argument that this system is racially biased. And of course, I think it's fair to say that it is. But of course, how you measure the bias is important. And depending on how you measure it, you can get different perspectives. And I think just very, very quickly, essentially what you can see is that if you separate the populations, the African-American population, the white population, and this is the argument that these populations are treated differently, you can look at, for example, well, who is considered to be higher risk, and you can see that there's significantly greater percentage of African Americans in this system are considered to be higher risk, 60% versus 35%. I won't go into the details of the numbers, but if people are looking at the video later, they can check out the details. Another form of bias is, well, I suppose one question is, well, is that fair? Now, interestingly, this data also tells you who has been rearrested, so who has actually reoffended, and the data does the prediction of who is likely to be higher risk is approximately equivalent to the likelihood of people reoffending. And so, uncomfortable as it is that these two groups have different scores, there might be some truth in this, if you look at it in this way. But of course, there are other factors one has to consider, like, for example, if there's an expectation that one population are more likely to be committing crime, then of course police forces will be deployed there, and of course police forces rearrest people, and so it's a self-fulfilling prophecy. So it's very, very subtle. Other ways of looking at these sorts of things is, well, if we look at our mistakes, who do we mistakenly think are likely to reoffend? And again, there's a clear difference between these populations. And if we look at, well, if we make a mistake but we make it the other way around, we give someone the benefit of the doubt, again there's a huge difference. And so one could argue that there's a significant racial bias in the data. But of course, one could ask, well, let's forget, for example, that these are two racial groups. Let's imagine that these are people living in Ireland and people living in Australia. And so, we want a system that makes good predictions for the Irish and good predictions separately for the Australians. And I think we're comfortable with that because, we're not so sensitized about issues of race and gender and everything else. And there's a measure called calibration, and both of these data sets seem to have pretty much equivalent calibration bias. Now, I'm not making the claim about whether the system is biased or not, but I'm just simply showing you that there are many ways of measuring the bias. But unfortunately, we can't eliminate them all simultaneously. So we can't make all of these measures balanced in an attempt to debias AI systems. So we kind of have to pick what kind of bias we're happy to live with and what kind of bias we're not. And that's okay, because I think we do that every day. For example, when we're dealing with, for example, the underrepresentation of women in technology, we create initiatives and we take purposeful action to improve their representation. And so we're comfortable with these ideas. And so it's, that sort of behavior that and that action that we take in the real world does actually have a correspondence in the mathematical world, and we shouldn't be too concerned about that. But if someone tells you that they're making bias-free AI systems, you need to be somewhat skeptical about that. Okay. On the common sense issue, just to give you a very concrete example, and I'm raising all of these just to give you a sense of how complex dealing with AI systems actually is. So on the question of common sense, we can look at what's called a Winograd schema. And a Winograd schema is a sentence. So in this case, the councilman refused the demonstrators a permit because they feared or advocated violence. Now, we can create two sentences, one where we use the word feared and the other one where we use the word advocated. We have these two sentences here. And depending on whether we use the word feared or advocated, the they refers to different groups. So, for example, if the sentence is, the city councilman refused the demonstrators a permit because they feared violence, we know that the they refers to the councilman. On the other hand, if we use the word advocated instead of feared, the sentence becomes, the city councilman refused the demonstrators a permit because they advocated violence. Now the they refers to the demonstrators. And none of us have a problem understanding this. But why have we interpreted it in that way? Because we have some common sense, we have some knowledge of the world about the concerns of councilmen, what councilmen might fear. We also have some common sense about what demonstrators might do and what they might advocate for. And all of this background common sense allows us to interpret the subtleties of those two sentences. And that's very difficult to automate. So when people talk about common sense reasoning, what they're talking about is the understanding of these terms that allows you to properly understand the sentences. And they're structurally exactly the same. The only thing that's changing is one word, but the meaning of the they and who the they refers to completely changes in each case. Facial recognition is a very, very big one. So there's huge concern around facial recognition, especially in Ireland at the moment. There's a lot of public debate and government attempts to introduce various forms of facial recognition, and I'll talk a little bit about that in a minute. And the AI Act specifically makes facial recognition for policing effectively illegal in Europe. And that might surprise some people, But of course, the reason is that that surveilling the entire population is considered to be disproportionate, given that the overwhelming vast majority of people are law-abiding. And of course, surveilling them changes their behaviors and it impacts their fundamental rights. And so that weighing scale very much tips against facial recognition and towards protection of fundamental rights. There's all sorts of issues on fairness. So it's easy to show that AI systems, that even though they perform well on average, might perform poorly for particular groups. So this is a piece of work by Facebook where they show that object recognition performs poorly for poorer regions of the world. And that's because, you know, the data sets don't cover those areas so well. And also the occurrence of objects in poorer regions might be far more complex than it is and non-uniform than it is in wealthier regions. So just getting onto the regulation side, I suppose I mentioned that to begin to regulate AI, we must have an ethical basis for it. But of course, who decides what the ethical basis is? And is there a sense that there is actually a single ethics that can underpin AI? And this is a very interesting piece of work that was done a number of years ago, the moral machine experiment. And what they do in the moral machine experiment is they present these trolley problems to users, 13 in all. You can go to the moral machine experiment website and you can undertake these little tests. And so you're basically controlling the car, and you have to decide whether you're going to let the car drive on or whether you're going to intervene. But in both cases, unfortunately, participants in the scenario will die. And what you have to decide is, well, which side of this do you want to be on? So, for example, on the left-hand side, if you do nothing, well, one man, two male executives, and one female executive will die. And on the right-hand side, if you intervene, then 3 homeless people and 1 woman will die. And you can start to see how awkward and kind of difficult this becomes. So it's best done on a Friday evening with a close friend over a glass of wine or something, because it can be quite fun. But what they've done is they've aggregated these responses over hundreds of thousands of people. And I suppose there is a pretty consistent preference for sparing particular characters. So, you know, there is a sense that we want to spare babies, we want to spare children, we want to spare pregnant women, we want to spare doctors. On the other hand, we're not happy, but you know, we do have a higher preference to not spare cats if necessary. So we sacrifice a cat if necessary, followed by criminals, followed by dogs. Which is kind of interesting. And you know, this can reflect then on sort of our preferences for actions, our preferences to spare certain genders, our values about status, our values about the law. And what they've been able to show in this work is that if you cluster the whole world based on the similarity of people's responses, the world kind of breaks out into 3 groups. So let's not worry about the label Western, Southern, or Eastern, but there are 3 groups. There's a red group, a green group, and a blue group. And so countries are similar if they respond similarly. So, for example, you see Armenia and Macedonia here. So they responded very similarly, so they're very close together. Whereas, for example, Iran and New Zealand are in very, very different groups because they responded very, very differently. And what's interesting is that when you look at the value systems in these 3 groups, and again, don't get hung up on the Western, Eastern, Southern thing, because you know, obviously this has lots of political connotations, and that's not the language that's used in the paper. You'll see that there are 3 very different value systems. So in this green group, they prefer to spare females, they prefer to spare higher status, they prefer to spare the young. On this red group over here, there's a great preference for inaction, whereas in the middle one, the blue one, they prefer to spare the lawful, spare human beings, and very much wish to spare pedestrians. And so there are 3 very different scenarios. And so the question then becomes, well, how could we possibly build a universal code of ethics for AI, and how can we build a universal law that oversees AI? And that's very, very challenging. So in our introduction, Joyce mentioned human-centric AI. And so the European Commission's perspective on AI is that we want AI systems to be human-centric. We want them to protect the fundamental rights of European citizens, and not just as citizens, but all human beings in the EU. And I make the distinction because not everybody who is living in the EU is a citizen of the EU. Some are refugees, some are asylum seekers, and they have exactly the same rights as the citizenry of the European Union. And so we just need to be careful with the language there. A number of years, as Joyce mentioned, a number of years ago, I was vice chair of the high-level expert group, and we were tasked with coming up with an ethics code for Europe. This was a group of about 52 experts. The chair was Pekka Lepitala, the tall gentleman in the center with the black and white striped tie, former president of Nokia. I was vice chair, and the members of the group came from a variety of backgrounds: industry, civil society, academia, people with expertise in philosophy, in social sciences, in legal experts, technical AI experts. So a very, very diverse group, pretty much gender balanced, and quite an interesting group to work with. We produced these ethics guidelines for trustworthy AI in April of 2019. We also did some policy investment recommendations, which I won't talk about today. And we characterize ethical AI as AI that was lawful, ethical, and robust. Sorry, we characterize trustworthy AI as AI that was lawful, ethical, and robust. And we identified 7 key requirements that AI systems should have. And these 7 key requirements are here: that AI systems should protect human agency and oversight, they should be robust and safe, and so on. And if you read the text of the AI Act, you will see that these 7 key requirements are embedded as the foundation stone for the current regulation. And neither in the European Commission's proposal of the Act and the European Parliament's compromise text on the Act, these 7 key requirements remain the bedrock of the Act. Now, of course, while these principles are things that we want to protect, how you do it is actually very challenging, because some of these things can be dealt with technically, but some of them cannot be. And so, for example, how you measure societal well-being, for example. Okay, so for listeners who are able to speak fluent GDPR, you will find the 7 key requirements reflected in the GDPR. We didn't set out to ensure that this was the case, but once we identified the 7 key requirements, we revisited the GDPR, and we could see that the GDPR does in fact uphold those 7 key requirements, which is very interesting. For those of you who are interested in assessments of AI systems, we've produced assessments